So let us now see the shift operators, which is left shift, right shift, and then we have another right shift. So this is signed and this is unsigned, or we can say this is zero fill operator. So we'll just see why there are two operators for right shift, there is only one operator for left shift. So let us first take the case of left shift. We say there is a value which is 6. So this will be 0, 2 and 4. 1, 2, 3, 4, 5, 6, 7 and 8. So in case I say this is A and I say A left shift by 1 position. So this means every bit will shift towards left by 1 and the extreme left bit will move out and there will be a 0 added in the extreme right. So this bit moves out, this comes in the extreme right, and now this is the new number which comes out after shifting. So this number becomes 1, 2, 4 and 8. 4 and plus 8 becomes 12. So this is the result of A left shift by 1. As you can see, if we shift by 1, the number becomes, originally A was 6, this becomes into 2. So if I shift by another 1, so this will again go, another 0 comes in the extreme right. So this number now becomes 1, 2, 4, 8 plus 16, which is 24. So this becomes 6 into 2 to power 2. So how many positions you shift a number, that will become number multiplied by 2 to the power the number of times you are shifting the number. So every shift leads to a multiplication by 2. So in case you multiply by 3, shift by 3 times, this will become A into 2 to power 3. However, while left shifting, we have to take care that you do not have 1 in the extreme left. In case you have 1 in the extreme left, then the number will change dramatically. Suppose I have 24, then I shift another, this becomes 48, then again shift another 0, another 0, I get 96, and then again shift. So this goes, another 0 comes, but the problem now is that in the extreme left I get 1. So this becomes 192, and as you are already knowing, the maximum value in case of byte on the positive side is 127. So this is expected because after 127 it starts in the reverse order from minus 128, then minus 127. So 192 is not a number which is possible in byte. So this number will now become a negative number. So while shifting towards left, we must ensure that the extreme left bit never goes to 1. In case the extreme left bit becomes 1, the number changes dramatically. If you want to see what number it now comes out to be, we can see 1, 1, 0, 0, 0, 0, 0 and 0. We need to calculate the ones complement. 0, 0, 1, 1, 1, 1, 1 and 1, and I need to add another 1 to the number, and I have 1, 1, 10, 1 carry, 1, 1, 10, another 1 carry, 1, 1, 10, another carry, 1, 1, 10, another carry, 1, 1, 10, another carry, 1, 1, 10. So this is the number. So this number is 1, 2, 4, 8, 16, 32, 64. So this number is 64 but with a negative sign. So 192 comes out to be minus 64. So as you can see, if you add 64 to this minus 64, so this will become 192. So for any number, if when you are shifting towards left, we must keep in mind that if the extreme left bit becomes 1, the number changes dramatically. So next we will see what happens when we shift the number to the right. So when we shift the number to the right, suppose we'll again take say 12. So we have the number 0. For 12 I need 4 plus 8. Suppose I have A as this, and I say A right shift by 1 position. So this is unsigned shift. So every number goes towards the right. So this goes off. There is a vacancy at the extreme left, and the system fills this with a 0. So now the number becomes this, which is 2 plus 4, which is 6. Originally the number was 12. So as you can see, this becomes A divided by 2. And if I further shift it by 1, so this also goes, another 0 is added at the extreme left. So this becomes 1 plus 2, which is 3. So this is again dividing this by 2. So as we had for a left shift, we have this A divided by 2 to power n. So this will be the result for any right shift operation where extreme left bit added is always 0. So the result in this case will always come out to be positive. And this is why we had two operators, because if I have a number such as 1 1 1 1 1 1, I have a number like this, and if I say shift by 1, now this number is negative because the extreme left bit is 1. Now if I shift this number towards right by even 1 bit, so this goes and the system adds 0 at the extreme left. So this number immediately becomes positive. So shifting a negative number with this operator will lead to a positive. So this is the problem for a right shift operator which is unsigned. So this is to take care of the sign. We have another shift operator which is signed shift operator. Now this will take care of the sign of the number which was there before the number was shifted. So again we'll take the same example. Now if instead of this 3 operator I use this signed operator and I have the same number. Now when I shift this towards the right by 1 bit, this goes and system has to add a bit here. So it will add that bit which was previously in the extreme left. So in case it was 1, it will add 1. In case it was 0, it will add 0. So negative number will continue to remain negative and positive number will continue to remain positive. In case we had in this case, so when we shift towards right, the system will check for the extreme left bit before shifting, which was 0, so it will add a 0. So positive number will continue to be positive and negative number will continue to be negative. So this is how the right shift operates with signed operator. In this case, the system will keep in mind the sign of the bit which was in the extreme left, and in this case system will not check for the extreme left bit, and always it will add a 0. So that is why we call this as a zero add operator, shift operator. This is a right shift operator. So we'll just check up if we get the proper values. Now as we have already seen that the shift, whenever we operate, the value always returned is an int. So in case I have int a is equal to, as we started off with 12 and we shifted this, I say 12 into 224 into 248 into 296 into 2. Now this is where the problem starts for a byte. 1 2 3 4. In case I right shift this by 4, sorry, left shift this by 4, int p is equal to a, left shift by 4. Now for a byte this was coming out to be a negative value, but for an int this will come out to be a proper value, b. So this will come out to be 192. So this is 192. Now in case I need to see the same result as we were seeing in our graphical representation, I need to store the result in a byte. So let us see what result comes now. So as you can see, it is minus 64. This is what we had got when we had seen shifting the bits by 4 positions. So shifting left, you need to take care of the extreme left bit in case it comes to 1, so it will create a problem. So similarly, if I shift this towards right, I say int b is equal to a, right shift without sign by 1, this will give me 6, and if I do it twice, it will give me 3. So this is how it works. And in case I have a negative number, say minus 12, and I right shift by just 1, so number comes out to be a positive number, altogether a different magnitude. And in case we use a single signed right shift, number comes out to be minus 6. So this is what we are expecting when we shift this number towards right. So minus of a number remains minus, whereas in the earlier operator, minus of a number goes to a positive number. So these are shift operators.